used to work at Google for almost 7 years, right?
Yep.
Who used to be a site reliability engineer and then a software engineer. Now he's an independent developer who made his own programming language called Elvish. And today he's going to share with us about the process of developing a new programming language in Go. So please welcome.
Right, thank you. Thank you for using my fancy way of saying unemployed. Yeah, welcome to this first talk after lunch. Let's all try to stay awake through this. I'm trying my best. Right, so I used a very clickbaity title. I promise I am actually going to cover the things that promised in my title. All right, so let's just jump into this. Let's look at the agenda first. So I'm giving you a very quick introduction to kind of the Elvish itself. And then the rest of the part, we'll try to focus on the implementation stuff. I'll talk about how to implement the interpreter and how to test the interpreter, because I promised 92% test coverage. And I also talk a bit about how you would test a terminal app. And then there are some miscellaneous bits, including the CI/CD stuff that I put in the title. All right, so what is Elvish? So the one sentence way of saying it is Elvish is a modern shell, and that reduces the problem to what is a shell. And I hope most people have used a shell. If you haven't, a shell is a programming language, but it's also a terminal app. And the way it's different from other programming languages and terminal apps is that it's a thing that helps you interface with your operating system. So that would be kind of the thing that we usually run in your terminal as kind of the first program you start in your terminal. I guess people are probably more or less familiar with the more traditional shells, like the Bourne SH is kind of, it's not the original, but it's pretty close to the original Unix shell. And there's C shell, K shell, Dash, Bash, Z shell. Bash and Z are probably the most popular kind of traditional-ish shell these days. But there's been kind of recently-ish kind of a batch of shells that try to be more modern. And by that, I mean they have like full-fledged programming languages, and they usually have like more powerful interactive features. And Elvish is one of them. There are other modern shells that you can use these days. There's a new shell, which is developing Rust, I think. There's a project called Oils that actually ships with 2 shells. And there's another project called Murex. It's a shell pun, and it's also developing Go. And Elvish is one of them. And today we are just going to talk about Elvish because it's my project. All right, so because Elvish is a shell, it has like all the traditional kind of shell language features. So these are the things that you can all run in Elvish. I hope they are more or less self-explanatory. So you can run external commands like vim main.go. This does exactly what you want, like the same as in Bash or Zesh. And you can it also has wildcards and text pipelines. So for instance, this is how you count the number of lines of all the Go files in the current directory. And Elvish improves a bit on that, in that it also supports recursive wildcards. So if you have like a Go project, you want to count all the Go file, the lines of all the Go files, you can do something like this. And Elvish also allows you to do this thing where you can capture the output of commands. And the syntax is a little bit different, but it's the same as like dollar parentheses or backquotes in traditional shells. So you can do something like this. Well, maybe a demo is warranted. Oh, well, let me first show the whoami command. It just prints your username. So you can do something. You can use the username as part of another command, something like this. All right, but we're talking about a modern shell, and Elvish has like modern language features in that it's like it is really a real programming language. So one of the things it has is it has actual lists. Traditional shells, some of them also have lists, but either you're just like pretending to use lists, but it's actually just white space separated strings, or you can have actual lists, but it only goes like one level. But Elvish has like you can do as many levels as you want, and this is how you do like a nested list. And it also has maps, which in the same way they can be arbitrarily nested. So you can define this one probably wants a bit more explanation. Like this is a 2-level map. this syntax, this weird syntax here, this is key value pairs. It looks like HTTP query parameters. And this one defines if this ultra map, the key is Go and Rust, and the values are also maps themselves. And they have two keys, compile and run. I'm trying to kind of capture the speed characteristics of different programming languages here. And you can do something like use the indexing to access, like first access the Go key, and then access the compile key. And this does what you would expect in other like modern languages, I suppose. Elvish also tries to improve on like traditional shell like outputting mechanism and pipeline mechanism, in that in shells, what you usually have is you can output lines and you can output like a white space separated values in each line. But that makes it very awkward to manipulate data that actually contains like new lines or contains white spaces. So for instance, if you have a string that's a list, like this is the name of the original three designers of Go, and they have like internal white spaces, and you want to split them by the comma, like it's like CSV. This is a very awkward thing to do in traditional shells. But in Elvish, you can do something like this, string split, and then this is the separator, and this will give you three individual strings that are kind of individual values, kind of like how you would manipulate kind of slices in Go. Slightly different, but you get the idea. And then you can also pass that through a pipeline. For instance, after you split into these three values, you can join them back together. For instance, here we want to join them back using pipes, and you get like a single string back. In case this looks familiar with like the names, they look like Go standard library functions. That's not a coincidence. I will talk a bit about that later, about how I was able to leverage Go standard library to not have to reinvent a new standard library. Like a lot of Elvish's standard library is just Go standard library. All right, and if we talk about modern language in this decade, we have to talk about functional programming. And every kind of new language kind of has that. Even old languages like Java is getting functional programming stuff. And in Elvish, functional programming, lambdas have a very lightweight syntax. It's just curly braces. If you put code in curly braces, that's a lambda. And if you want to declare arguments, it looks like this. And one interesting thing is once you have lambdas, they actually pop up everywhere. You start wondering, like, how could you program without lambdas? So for instance, Elvish has this function called peach. What it does is it's called this way because it's parallel each. What it does is that it takes a lambda, and then it takes some data, and it will call the lambda for each of those data in parallel. So you can use it to do fancy things like I have two servers and I want to run apt update on both of them, but I don't want to wait for one server to finish before doing the other. You can do this very easily in Elvish. In traditional shells, you have to do like a background pipeline stuff, or you have to resort to external tools like GNU Parallel. But in Elvish, this is all built in just thanks to the fact that it has lambdas. And if you want to know how fast a piece of code runs, you can just pass it to the time command that tells you how long it runs. This runs in roughly 1 second. That should be not a surprise. And also control structures in Elvish also use lambdas. Like for instance, you can do something like this if the uname, which just gives you the operating system name, like it does something for Mac users. And also prompts in Elvish is also defined using a lambda. Like in Bash, you have this variable. If you have tried to customize Bash yourself, you have this PS1 variable, and you have all those weird like % sequences. And that's just not a thing in Elvish because you don't need to remember any like DSL-ish like special sequences. What you do is that you just define some code that tells you what the prompt should be, and that's everything you need. You don't need to remember %U for user, I think, %H for host. Like you just like use whatever like normal code, just put in a lambda. Okay, I also talk about interactive features, and I just do a demo. So Elvish has syntax highlighting kind of out of the box. We have all seen this, and there are also other features, like there's a built-in file navigator that you can trigger with the Control-N, and this gives you like a column view of your file system, and you can go in, go out. This is very handy if you're like just exploring a new project, something like that. And it has like location history, and you can trigger with the Control-L, and you can also filter on that. and then you can go to any direction you have been to before. And tab completion, that's pretty standard. And there's also command history. You trigger with the control R, which is kind of the same as in bash, but the difference is that it gives you a list of everything you have typed before, and you can like quickly filter that. Like, this is my beautiful ffmpeg command that I would never know how to write from scratch. Okay, I covered everything. All right, so again, this is GopherCon, so let's talk a bit more about Go stuff. All right, so let's first talk about how to implement the Elvish interpreter. So this is kind of a case study of how you would implement an interpreter. Like, this kind of thing probably applies to any other language if you're interested in writing a language interpreter yourself. So people talk a lot about like compilers, compilation stages, but an interpreter also kind of works in stages. In the case of the Elvish interpreter, there's 3 stages. The first stage is parsing. It takes code, which is just a bunch of text, and turns that into a syntax tree. And the syntax tree is a tree where each node contains syntactical information. And then Elvish also compiles that syntax tree to an op tree, op4 operation. And each node now contains information to how to execute. And each node type also implements an exec method for execute. So we're getting kind of closer and closer to like the source code to actual execution. And the execution stage is just calling exec on the root of the op tree. And each of those stages is just divide and conquer on a tree structure. If you know how to do divide and conquer on a tree structure, you have solved like the majority of the problems implementing an interpreter. And if people are familiar with the literature of interpreter implementation, this is sort of a tree walker, but it's not a like traditional AST tree walker. It's a tree walker with a compilation stage, sort of. Okay, so that's a bit abstract. So let's look at a real example. So this is a very simple like shell program that you probably wouldn't write. It's not very useful. It just counts the number of characters in your PID, but it's a reasonable example for us. So this is the source code. The source code is just like a string of text, right? But after parsing, it becomes a tree because that is actually kind of the underlying structure that we are thinking about when we program. It's also the underlying structure that you need to actually interpret this code. So this whole thing is a pipeline, and each of the pipeline has 2 commands, and for some interesting internal reasons, they're called forms in Elvish instead of commands, and it has 2 forms. And each form has, this is the name of the command, it's called the head of the form. For instance, the first form, the head is echo. It's a bare word, meaning that's an unquoted word. And then it has an argument, that's PID, and the type is a variable. And the second form, similar. It's a WC command. And the syntax tree gets turned into the op tree, which you can see pretty much mirrors the same structure of the syntax tree, except that it does come with a little bit of new information. So for instance, here it's able to recognize that the echo command is actually a built-in command. So it has annotated with this scope information. And there's interesting detail in the Elvish where each function is actually just a variable with a funny suffix, with a funny tilde suffix. So this is how it resolves the echo command to a variable that's echo tilde. And then it also resolves the scope of the PID variable to a built-in variable. And then finally, the WC command resolves that to an external command instead of a built-in command. And we'll talk a bit about the exec method a bit later because that requires some real code. All right, so parsing, I'm going to give you a very high-level introduction of how to implement what's usually called a recursive descent parser. So when you're parsing, what you do is that you pretty much only need like a single bit of information. So you have the program source code, and then you need to keep a pointer to which character you are going to look at next. This is our next pointer. And there usually is there's a bit of jargon when people talk about parsing. For instance, what does it mean to peek? And what does it mean to consume? And to peek simply means to look at what next points to. For instance, if we are here, if we peek, we see E. And to consume simply means move the next pointer ahead. So if we say we consume E, that means we move the next pointer after E. If we say we consume echo, that means the next pointer now points to after echo. All right. And as I said, like everything in here is really just divide and conquer on a tree structure, but we don't have a tree structure yet. What we have is text. So in this particular case, this tree structure is in the algorithm itself. So you start asking yourself the question of how do I parse this thing? And you break it down into smaller pieces. So for instance, we are now trying to parse a pipeline. And how do I parse a pipeline? To parse a pipeline, you parse a form, which is kind of Elvish jargon for a command. And then as long as you still see a pipe, you consume the pipe and then parse another form. That's how you would parse a pipeline. And the way you parse a form is, again, it's divide and conquer. You first parse an expression and use it as the head of the form. And as long as the form doesn't end, which in like a low-level speech means that as long as we don't see a pipe or a new line, you continue to pass another expression using it as an argument. And then you go down and down. This is the descent part. And I mean the recursive part is within like you call smaller and smaller units. All right, so this is some kind of toy code. It's not real code, but it's close enough to the real code. So for instance, the parser just has the source code as a string and the next pointer, and the pipeline is just a struct that has forms as its children. And if we want to parse a pipeline, what we do is, the comments is just what I said earlier. To parse a pipeline, you first parse a form. That means we call a parse form function, which I'm omitting. I'm only doing one level here. And then as long as you see a pipe, so if you pick the parser and you see a pipe, and then you consume the pipe, which is just incrementing the next pointer, and then you parse another form. And finally, you just like return all the information that you have obtained. And this is like one level of parsing. And each level like under it works pretty much the same way. That's why it's called like recursive descent. And you will see that the recursion relationship exactly mirrors the syntax tree that you will be defining. So for instance, the parse pipeline calls to parse form, that corresponds to these kind of two edges there. All right, and to compile a pipeline, you also do the same thing, kind of divide and conquer on the tree structure. And I'm kind of cheating a bit here because I'm only covering like a very simple case of compilation. So to compile a pipeline, what you do is you just compile all the individual forms within the pipeline. I think this will get a little bit easier with the functional programming stuff that's coming in the standard library, but this predates all the generic stuff. So it's like, it just uses a loop. Actually, the combination of other nodes is much more interesting. So I mentioned earlier that the compilation stage can resolve like the echo command and the WC command to two entirely different things. This is just a built-in command. This is an external command. We don't have time to go into all of that, but if you're interested, there's an actual link in the code. All right, but the execution part is probably it's a bit more self-contained. We can talk about that in a bit more detail. So also it's probably the more interesting one because like parsing is really pretty much the same as other languages. I think the Go standard library contains many recursive descent parsers because I think the original authors really like handwritten recursive descent parsers. So my example may not be the best one to follow even. Right, the exec method is where the real actions happen and is what makes kind of Elvish kind of a bit different from other programming languages because it has all the shell semantics. So let's consider like how you would write a exec method, like how the interface works. And let's just start with saying that it's just a method that doesn't take anything and doesn't return anything, it just has side effects. And so we will have a pipeline op that just has a exec method, and we have a phone op that has an exec method. But if you think about how the different commands actually execute, you will realize that doesn't actually make sense. Because when you are executing this command, echo $PID, pipe WC, the echo command and the WC command actually executes in not in very different ways, but they execute in very different contexts. Because the output of the echo command is connected to the pipe, but whereas for the WC command, its input is connected to the pipe. So the solution for that is just to create a context of which you can live. And this is kind of a simplified version of the context. So we have, because Elvish supports like value inputs, value outputs, we have, but it also supports the traditional kind of byte inputs, byte outputs. So the standard input is actually a pair of fields. There's a file, but there's also a Go channel. And the standard output is also a file, but there's also a Go channel. And the standard input is just for reading, standard output is just for writing. And all those methods will take the context as an argument instead of taking nothing. All right, and this part is probably the most interesting one, and it tells you really how, kind of the meat of how you implement a shell or shell-like language in Go, and it uses very familiar building blocks. So this is not as complex as the real implementation of pipeline op.exec, but it shows the interesting bits. So for simplicity, we're just going to assume that we only have 2 forms, because we have multiple, there's a bit more bookkeeping that needs to go on. And what we do is that we create the byte pipeline, which just uses os.pipe. That's kind of just a very thin wrapper around the pipe syscall. And for the value pipeline, it's just a channel. So we just create a Go channel. And then the pipeline itself exists in the context, but now we are going to create a slightly different context for the 2 different commands. I didn't write out the implementation of clone with the std out, but you can probably imagine that. It's just copying all the fields, except for the 2 std out fields. So for the form 1, the context just changes the standard output to use this is the writing end of the pipe, and then this is the channel. And for form 2, we use the reading end of the pipe and the channel. And then this is kind of the standard drill of how you would like fire 2 parallel tasks using Go routines, right? You use a wait group, and then you use a Go routine to execute the first form, and then use another Go routine to execute the second form. If you know this, you know like 50% of the secret of how to implement a shell. All right, this is the same slide from before, just a reminder of what we have done. We go from source code to a syntax tree, and then we go from syntax tree to the op tree, although the more interesting bits actually happen in the exec method of each of these different nodes. Right, so Go is actually great for writing a shell. Kind of surprisingly, some people thought Go wouldn't be a good language for writing a shell, but actually it is. We have seen that the text pipeline is just os.pipe, and the value pipeline is just channels. Well, this is kind of an Elvish specific thing. But you would have concurrent execution in all the pipelines, and that is just Go routines and sync.wait group. There's one thing I didn't cover, which is the other 50% of the secret of implementing a shell, is that a shell needs to run external commands, and that is actually just os.start process. It's surprisingly sufficient for everything you need to do in a shell. And Go also turned out to be actually a pretty great language for writing an interpreted language. So one thing that Go kind of I get for free from writing in Go is Go has big numbers. It has the math/big library, so it has big integers and big rational numbers. Big rat, that sounds very funny. So in Elvish, you can just calculate 40 factorial. You don't and not worry about overflows. And you can add 0.1 and 0.2 together and get 0.3, although you have to use the fraction syntax. And because the Go has a pretty good kind of battery-included attitude towards standard library, Elvish just just mass copies. So, like the math library, the string library is spelled a little bit differently in Elvish, and the regexp library. So if you know the Go standard library, you know the Elvish standard library, basically. You can do all those fancy stuff. And another thing that wasn't actually very obvious in the beginning was that if you write an interpreted language in Go, you get garbage collection for free. Because for instance, if you're writing Rust, you have to actually implement a garbage collector, because, for instance, Rust doesn't have a garbage collector. But in Elvish, because an Elvish value is just a Go value. When some Elvish code goes out of scope, the corresponding Go construct also goes out of scope, and that gets garbage collected. All right, let's also talk a bit about testing stuff. All right, so how do you get to 90% plus test coverage? I think there's like one answer to that. It's making writing tests really, really easy. If you make writing tests really easy, you will write a lot of tests and you get a lot of test coverage. That's kind of just like a chain of logic there, right? And it turns out that interpreters are actually very easy to write tests against because they have a very simple API. So the input of interpreter, we have seen before, is just code. You don't actually need to input like the syntax tree or something. The parser does that for you, right? And the output is just text. And in the case of the Elvish interpreter, it also has like individual Go values. All right, so let's write kind of a classical table-driven test for Elvish, for the Elvish interpreter. And this is how it would look like. So the input is just code, and the output is we define what kind of values we want, and we define which bytes that we want. So for instance, if I want to write a test against the echo command, this is what I do. The code is echo full, and the bytes I want is full and then a new line, because the echo command actually implicitly adds a new line for you. And the interpreter test, it will just be iterating through all those test cases. And imagine the previous slides, the 3 stages is all captured in this interpret function. And then this is what you would do. Like you actually run the code, you see what values and bytes you get, and then compare it to which ones you were expecting. So this is pretty standard stuff. And a lot of like Go tests are written in this kind of classical table-driven way. And it was for a very long time how most Elvish interpreter tests were written. But now let's look at like what actually happens in the development flow when you're like trying to add a test case within this framework. So let's say I'm trying to implement a new command, string column drawing, and this is kind of the namespacing thing. And what you would do is that first you will write code to actually implement the new functionality, right? And then I would test manually in the terminal. Like for instance, this is how I would do that. Oh, and I see that it works. It gives me what I was expecting. And then I would translate that interaction into a test case. I would translate that into this. Like code is this, and the values I want is this. But the thing is, after I have done manual testing, I pretty much feel I should be done. I shouldn't really need to like kind of do the conversion, right? And we have a computer to use, and we can actually let the computer do the conversion for us. So the idea is to, what if we just record the terminal transcripts in a file? So for instance, this is the terminal transcript that we have seen before. And you can see it is kind of semi-structured. Like this is Elvish's prompt. It's a kind of this funny thing. And this thing marks that it is an individual value output. And we can write a parser to do this, right? And we don't even need the kind of sophisticated parsing mechanism because we can just look at how each line looks like. And then we can convert that transcript into kind of this particular structure that we have seen before. So underlying all the transcripts, it's pretty much the same structure. And so why don't we just write a simple like parser, like parse transcripts, and then do exactly the same thing as before. So there is a bit of a leap here in that we have embraced the text format instead of like using actual like Go structs. And we actually lose a bit of strict structure there. So for instance, this doesn't allow us to distinguish like, what if it's a command that actually prints those things into the byte output? Like, what if your byte output happened to start with this? Then you have a problem. Like, the parser will think that it's actually value output. Or what if your output happens to contain lines that contain this prompt? Like, you get very anxious when you're trying to like, kind of lose this structure. But my experience is that it actually doesn't matter in practice. Because if you happen to have some test code that needs to output like something like this, just rewrite your test so that it doesn't output something like this. All right, so now this is how it works sort of how it works today. So you would implement new functionality, and then you would test it manually in terminal, and then you would copy the terminal transcripts into a test. And let me do a quick demo on this. So, and just to make the point, I've actually tried to make a mistake when I try to copy the test. So let's say this is a new test that we're adding, and let's say when I copied, I left out something. And this is so that we can actually see the test failure. And if I run go test, right, this one tells me that, it actually doesn't output the thing that you were expecting. Yeah, but normally what I do is that, it's pretty hard to make mistakes when just copying, right? There's something wrong. Oh, okay, it doesn't like the new line there. Okay, and we have a passing test case. Actually, let me put this in this this individual section. So this is then for a while how most tests in Elvish were written. You would test in the terminal, and then you would just copy paste into your editor. But then we still need to do copy pasting, right? And programmers are lazy. We don't even want to do copy pasting. So, so to solve that problem, you can what I did was I wrote an editor extension for VS Code in this case. So what you can do is there's just a key that will just run the code under the cursor, and it will input it will insert the output below the cursor. So again, it's the same thing. Let me write something slightly different. And then, so I wrote a VS Code extension where if you just press Option, Enter, you get this. So we have eliminated step 3. So we have pretty much eliminated test writing as a separate step during development. Instead, what we do is just we write the code, we do some manual testing directly from within the editor, and that becomes your test. Well, you still have to save, like you press Command S, so but instead of Command C, Command V. And that's how you get 90% plus test coverage. Just make writing tests, just make you not think about actually writing tests. If you just do your manual testing in your editor, that's your test. Right, and let me also talk a bit about how I tested the terminal app, because as I said earlier, Elvish is not just the interpreter, it's also a terminal app. And again, let's do kind of a quick study of before this, let's talk a bit about how the terminal app is actually structured internally. So it has this thing called widgets, if you have done GUI programming, you're probably familiar with the concept. Elvish is a terminal app, but it also has the same concept, just for breaking things into components. And the widget has 2 methods. It has a handle method, which just handles an event, and it has a render method, which tells you how it looks like. So there are some more types here, for instance, the buffer type. What it does is that it stores rich text and the cursor position. And what do I mean by that? So if you look at the state of the command line, it's not just text. It's mostly text, but it's not just text. For instance, this text is green, and the cursor could be here. The cursor, if I press the arrow key, the cursor could go anywhere. So it's mostly text, but it also adds this additional kind of style information and the cursor position. And the event type, for our purpose, let's just think of them as keyboard events. There are other events, but they're a bit less important. And one of the widgets, the most important widgets in Elvish, is called code area. What it does is that, it stores the text content and the cursor position, so it would know how to show them during render. And the way it handles events is how you would expect a text editor to handle events. You can insert text, you can delete text, you can move the cursor. So what I've shown before, this main thing here, this is the text area widget. So if I press E, it inserts E. If I press backspace, it removes something, and using arrows to move the cursor around. All right, so when I talk about testing the terminal app, it's actually a bit hard to test the entire app, so we don't have a lot of tests for that. Most of the tests are just target individual widgets. And now let's look at the widget API. So it is simple-ish. It's slightly more complex than the interpreter, but it's still simple-ish. So because the input is just events. And for our purpose, we just think of them as like keys. And the output is buffer. But the thing that makes it a little bit more complex, that's why there's ish in parentheses, is that when we are testing a widget, we often have multiple inputs and outputs, and they're often interleaved. So for instance, a typical test will look like something like this. So press X and Y, and then check what it shows. It should show X and Y, right? And then press left, and then check what it shows. It should still show left X and Y, but then the cursor is one position to the left. And then we press backspace, and we check what it shows. It should now delete the X, because we just moved the cursor left before. So I've tried several different styles of how to write this test. I've tried like table-driven tests. I've tried just writing tests in Go code. But they all kind of end up a bit verbose, and they're not terribly easy to write. And that kind of goes against what we're trying to set out to do, is trying to make tests really, really easy. All right, so it turns out that we have a scripting language at our disposal. And that scripting language is just Elvish itself. And it already has a very great testing experience. So why don't we just create Elvish bindings for the widget, and then just write those tests as Elvish transcript tests? So this is the same test that we have shown you before. So for instance, we can do something like this. We can send keys, X and Y, and then we ask the widget to render itself, and it should show X and Y. And press left, render itself, send backspace, you should have deleted the X. So if you are familiar with the front-end testing, this actually looks a lot like screenshot tests. Instead, in screenshot tests, what you do is like click something and then check against the screenshot. Except that it's actually even better than screenshot tests, because in screenshot tests, you have screenshots saved as external image files, whereas in this case, the image files is really just those text. All right, but you must also have noticed that this is not the real story, right? Because when you have press left, this doesn't show us where the cursor is. So how to do that? You just make the text output slightly more complicated. This is how it actually looks like. So I think I'm actually going just to do a demo here. So let's say we send ECO and then enter. So the test widget doesn't have a prompt, so it's just the code, but it does have syntax highlighting. So in Elvish, if a command is unknown, it will be shown in red. If a command is null, it will be shown in gray. So we also want to check against that. So if I run this, I have this format where each line actually becomes two lines. The first line is the text, and the second line shows you the style of each character just above it. So for instance, the capital R just means red, and then there's this very funny looking thing that just shows you where the cursor is. Okay, and now let's send a key that's left, and then render. And this shows you that the cursor, if you look at, it's a bit subtle, but this small hat thing has moved to the left. Well, what's working under the hood is this is actually some Unicode combining characters that looks like a hat. Okay, and now let's type an H. That should make this a valid command. Yes, and you can see that the style has changed from R to G, and this is where the cursor is. All right, so that's how tests in Elvish are being written these days. But unlike the interpreter that I talked about before, the terminal app, the tests are just starting to adopt this pattern. They're not, but they probably should be all using this pattern pretty soon. And after all the terminal staff have adopted the pattern, I do expect the test coverage probably be a little bit higher than 92%. All right, more stuff. Elvish has a continuous deployment thing. I don't know how exactly to call it. A pipeline. It's not exactly a pipeline. It's a very small pipeline. And I realized that it's actually much simpler than I originally thought, so I only made like one slide for it. So I think the thing is just like Go is a very great language to write a web server in, and Elvish is actually a great language for writing scripts in. So when you combine them together, Like you can do continuous deployment very easily. And the architecture looks like something like this. So I have a £5 per month VPS, and it serves the Elvish website. And this part is not part of the CI/CD pipeline. But this part, sorry. These two labels should be swapped. This is user accessing the website. This is developer pushing to GitHub. And GitHub has this feature called a webhook. It basically says that you can define a web endpoint that GitHub will call at each event, for instance, pushing code. So you can define a webhook for pushing code. And then I run a webhook listener in Go that listens to those events. And what it does is that it just runs an Elvish script that builds binaries. So for instance, let's see. It's actually a bit hard to see if I don't, maybe I can push something to, but anyway. What it does is that it builds all those binaries in this server. And you can see, let's try to find head. Oh, right, the head is right at the top. So this was just like pushed slightly earlier today. And this is all just driven by an Elvish script that builds everything. And if we can probably look at the code a little bit. So everything is really just here. There's a single file Go project that's an HTTP listener. It's less than 200 lines of code. And what it does is that it listens to a port, and there's a little bit of validation going on, and to be honest, that's the only complicated thing. And then there's a master hook, which is just an Elvish script that builds binaries, and there's a tag hook that's another Elvish script that builds binaries for tagging events. Master is for pushing to master. All right, let me also talk a bit about kind of my personal perspectives of building this project. So the project goes back to 2013, and that was a time when Go was really a very new language. People still talk of Go as a new language today, but back then it was really a new language. It was a fancy language that just came out that was designed by like familiar names from biolabs. So that was part of the reason why I started using Go for Elvish. But to my surprise, Go 1.1 was already a very solid language for writing Elvish. And it has all the pieces that you need for shells that I talked about before, Go routines. Go is famously known for Go routines, and all the parallel execution mechanisms, like the channel mechanism. All the fundamental stuff was already there in Go 1.1. What did change a bit, Elvish code a bit, was like modules, because everybody's project was changed by modules, and generics and fuzzing were also quite interesting, but not like world-changing, but they did have some interesting impacts on Elvish. One of the things that I discovered with fuzzing was that there was actually a bug in the parser that would result in exponential time complexity. And sometimes it could take 2 to the n time to parse some code where n is the size of the source code. And that was actually discovered by fuzzing, because the fuzzers just kept timing out. And I was thinking, I should report this as a bug to the Go team, and then realized it was actually a bug in my parser code. So I'm quite happy with Go as kind of a language for implementing Elvish, but I do wish it has some more things, like nil safety is a bit annoying. I still get crashing bugs in Elvish, and they're almost always caused by me forgetting to handle a pointer could be nil or interface could be nil, which is always a bit embarrassing. And plugin support on more platforms. Like today, you can write Elvish modules in Elvish itself, but you can't write Elvish modules in other languages, for instance, in Go, because Go does have dynamic loading support in its standard library, but it only supports Linux and Mac OS, I think. All right, so the interpreter is kind of sophisticated, but it's actually not a lot of code, especially if you, like me, if you just focus on the simplicity of the implementation and you don't worry too much about the performance. It's actually very easy to write an interpreter as long as you master the techniques of divide and conquer, and you just reiterate on that on multiple levels. That's how you write an interpreter. But the terminal app actually turned out to be a lot of code. That was a bit surprising to me. All right, you can learn more about Elvish. You can visit the website. It's very easy to remember, the domain name elv.sh. And let me zoom in a bit. And it's very easy to just install Elvish on your computer. It gives you like a one-liner that just, it doesn't pipe a script through bash or something. It just gets a file and uncompresses it in your /user/local/bin, because thanks to Go's static linking, that's just how you would install a Go command. Oh, and you can always try Elvish without replacing your existing shell. I think this is a common misconception. When I ask some people why they don't want to try Elvish, because they always say they don't want to abandon bash, but you can always use it kind of just as an ordinary program that, like you use Vim or like other programs. And if you're really happy with it, you can like set it to your default shell. And you can also try it within your browser directly, if that's your thing. It's probably a bit hard to see. The domain name is just try.elv.sh. And you can do, right, there isn't any files here. Yeah, but you can do all the things I've shown you before directly in the terminal. And there's a GitHub repo, of course, and there are some developer docs. Right, we have 14 minutes. Let's use this time for questions if you're not asleep yet.
Okay, thank you so much. Yeah, you had a question?
I'd like to ask, can you write a fork bomb in Elvish?
Right, what?
Can you write a fork bomb?
That's a very good question. I mean, a fork bomb. The thing with Elvish is that, like in traditional shells, pipelines are run in different processes. That's why you can write that's why you can like exhaust a number of PIDs. But in Elvish, pipelines by default, if you like write a function in Elvish, it's not run in a separate process. So you can do something like this. Right. And it will just continue run forever, and eventually it will exhaust the number of file descriptors in Elvish, but it's not going to like exhaust the number of process descriptors in the system.
Thank you.
And oh no, I can't.
No more demos.
Okay, at least it's not going to freeze my entire machine. Like this process is dead, but yeah, thank you. I will never do that again.
Yeah, sorry, just one question here. I think you mentioned that you started this project in 2013. I'm sitting here, if you can't see me.
Oh, sorry.
Yeah, so I'm just interested in knowing like why initially you started looking into creating this shell. What problems were you trying to eradicate, like the other shells that you were using weren't able to do? So what was your thinking behind developing this?
Yeah, so I think Elvish is one of the earlier kind of modern shells. Like I listed several other modern shells in this slide. They were all started after Elvish. So when I started Elvish, there wasn't a lot of like choices. Oh, I forgot to mention Fish here, because I think Fish is kind of in an awkward spot where it's, in terms of expressive power, it's kind of similar to traditional shells, but the language is better, it's cleaner. And in terms of it does have a lot of interactive features, but the language is not very strong. So what I was thinking at the time was that, like, why don't we write lambdas in shells? That was kind of the original idea of why I started this shell. And then kind of the more ideas kind of got adopted, and I think we're much better off if I have a real programming language at our disposal as the default program that you run in the terminal. Also, if you have read any kind of batch scripts that's longer than 1,000 lines, you start questioning your sanity and why you don't write a shell yourself. And that was one of kind of my breakdown episodes that led to me writing a new shell.
Hi. So the way that you write the tests is very cool with like just the text file. Did you use any of the fuzzing to just basically expand on all those different tests? Or how did you incorporate fuzzing into your test writing?
Right. That's actually a thing that I want to work on a bit more. So right now, Elvish does use fuzzing, but it doesn't actually use it in that many places. Like one thing I mentioned before is that it fuzzes the parser. But if you, let's see. Yeah, if you look at, if I search for func fuzz, there isn't that many places where it uses fuzzing. Like there's a, this is what I mentioned earlier, is it fuzzes the parser to make sure it doesn't crash or it doesn't get very slow. And it has a few other interesting applications. One thing I will mention, because you asked about fuzzing, is that Elvish has its own Markdown implementation. And one thing I used fuzzing to great effect for is that it also, like, because it has its Markdown implementation, also has my own Markdown formatter, because it was because Prettier was I was using Prettier at the time, and Prettier was very slow at the time. So I decided to write my own Markdown package. So, but the thing when you're writing a formatter is that you don't want it to actually change the semantics of the source code, right? In case of Markdown document, so you can write a fuzzing test to make sure that the Markdown file before and after formatting actually generates the same HTML. So that's the thing I use fuzzing for, and we also use fuzzing for just to make sure that the compilation stage doesn't crash. But I actually want to use fuzzing to make sure that running Elvish code doesn't crash. But that is a very dangerous thing when you actually have like, because that's a remote code execution vulnerability right there. What if like the fuzzer decides to come up with, oh sorry, this process is still dead. Because the fuzzer could just come up with this, right? And how do you, and you need to defend against that. So one thing I've been thinking about recently is to make Elvish kind of sandboxable. So you can do fuzzing when it's properly kind of sandboxed, so that it doesn't delete your root partition when the fuzzer came up with this. Or when it comes up with but it can still come up with this. So that's not very good. It's more to think about.
Okay.
How is the web terminal implemented?
You can see the source code is on GitHub. Well, I didn't implement the terminal itself. There is a project called GoTTY. So what you do is that you run GoTTY, and then GoTTY, what it does is it runs it as a fixed user. And then I have this, I should rewrite this in Elvish, but it's still a bash script now. So what this does is that anytime anybody visits the website, it runs this script, which what it does is it creates a new user, and then it changes to that new user. So every time you open the terminal, it's actually a different user. Like this is elf74, and this is elf88. Like so it's a new user every time.
Is that running on your VPS?
Yeah, that's on another VPS of mine, because I don't want vulnerability in this thing to affect the main website. That's another £5 per month VPS. It adds up very quickly, those £5 per month VPSs.
Any more questions from the people? Can I ask you, you mentioned this way of testing where you record the text output. You mentioned that there was also, besides text output, there was something else like variables?
Oh, there's a byte output and there's value output. So
value output, yeah.
That's kind of a feature of the Elvish language. So in Elvish you can do like echo, like full bar, and this is, well, why don't I just show in the terminal? So echo full bar. And this is byte output. But you can also do like put full and then put bar. And this is value output. So In this case, this is just a single string that has a new line like in there. This single string it's not technically a string, it's a string of bytes that has a new line there. And this is a string of values. And you can do something like this. And these are two separate values. One of them has a new line in them. Like in traditional shells, it's very awkward to express this kind of structure where you have, because if you just do this, like who is to know that the first two lines belong in the same value? But in Elvish, you can do this kind of thing. We can preserve the value kind of boundary of things. And also, of course, you can have more complex data structure from them. Like, because in traditional shells, you only work with the strings. You can't really work with the lists and maps when you're like writing an output. Elvish allows you to do that.
I was going to ask how you test that, but it looks like it's still the text output. It just, looks different.
It just looks like text output because the terminal doesn't actually have a way to represent like those individual values, but internally it's individual values.
Yeah, I really like this philosophy of I want good test coverage. Let's make testing super easy. It really seems to work well. Any more questions from anyone here, or should we finish? Okay.
How do you decide what are built-ins into the shell and then which ones are external commands? Because some of the things like WC are quite simple and could easily be implemented as a built-in. So how do you decide what is included or not?
Right, that's a very good question. So the way I try to approach this is that I try to approach this more like a programming language rather than like a traditional kind of toolbox kind of way of thinking. So Elvish doesn't have a WC command, but Elvish has, for instance, you can count how many lines there are very easily, and like it's more like it's a bit more low level. It's more like for instance, the Go standard library doesn't have a WC function, but instead it allows you to count how many characters there are in a string, and you can count how many new lines there are in a string. You can do something like that. So. But sometimes, like, users really want something, so sometimes I do give in to kind of the pressure from users if they really want something. But most of the time, it feels more like a programming language. Like, if you, like, these are, for instance, I mentioned earlier, the string, the str, like, library is just like pretty much Go's str library.
Okay, we have 3 minutes left. Is there any more questions? Yeah.
Does it use the same read line command that a standard bash uses? So if I do something like set -ovi, does it use the vi read line?
Oh no, it has its own kind of terminal, or the terminal bells and whistles. It doesn't even use like any existing Go terminal library. It just uses its own stuff. It's all from scratch, the terminal app aspect.
Okay, we have 2 minutes left, and maybe one last question we could take. Anyone? Yeah. Could you pass down?
What happens, basically when you type a command, everything's already been pre-compiled into the Go binary that's running. You're not building another Go binary that then runs the Elvish command. Or
No.
are there instances where that would happen?
Oh, so I guess that's because I talk about compilation. It's not like anything like a binary compilation. It's just kind of an internal compilation stage. So it doesn't compile into actual binary code. It just compiles into this op-tree structure that I talked about earlier. So I guess you can call that compilation, but I guess it's a little bit confusing.
Okay.
All right, if you have more questions, I'm sure you can find my email pretty easily if you just peek into the GitHub commits, but but you can join the community. There's a forum, there are chat rooms, and you're all welcome there.
Okay, thank you so much for sharing.